How's it going, everybody? In this video, I'm going to break down the EIGRP metric calculation for you, give you an idea of what exactly makes up the metric calculation, why EIGRP does what it does, and once we have an idea of how the metric calculation works, it'll make it easier for you guys to understand the whole purpose of adding all the details up and taking the bandwidth and delay and adding them together, getting the metric, and at the end of the day, we'll be able to determine why we are choosing one path selection over the other and going from there. It's relatively straightforward, but it's still important for you to understand the technicalities behind it. So, as you can see right here, this is the actual calculation. It's this really weird looking math problem. Or I should say equation, not or formula, not problem. So basically, I'm not a math whiz. I definitely don't do math for a living. I usually let the router do its own thing. But basically, at the end of the day, what you're going to be doing for at your base is bandwidth and delay are the default metrics. So we'll take a look at exactly which k values equal that, and so you can determine if the right k values are being used. And normally what I do is, if I'm not sure if they're being used correctly, I will copy in what I see and let that roll. Most of the time, unless you're in a lab environment, nobody ever modifies the metrics. Unless you're dealing with some sort of, unless there's a reason for it. And typically the only ones you would mess with is delay. But most of the time that's not even bothered. If you tweak the load and reliability k values, then what you could potentially have a problem with is, as the link gets saturated with traffic, you can actually run into load issues, and load issues can then lead into reliability issues. And the moment that the metrics change for load and reliability, or load or reliability, depending on how you implement it, your router can actually go into what they call to EIGRP churn, which means that it's constantly going to be running dual to figure out the best path. And typically, you'd want to steer away from that. By default, like I said, is bandwidth and delay. So it takes the inverse bandwidth. So it takes the slowest bandwidth from in between two routers. So if you've got 11 routers in between the source and destination, it finds the lowest bandwidth, takes that, and then it adds a cumulative delay of every hop, and then it takes that information, adds it together, throws it into the EIGRP metric calculation, and voila, you get your obscenely unique and very large metric value. Now, one thing that's commonly misunderstood is MTU is actually a k value, but it is never used in the actual calculation, and that comes right out of the horse's mouth from Cisco. The gentlemen's names are Don Slice and Donnie Savage. Those are the two guys that I've seen the most of talking about EIGRP. Donnie Savage kind of owns EIGRP. He basically built it from what it was to what it is today. So that is basically that's what they told me. So I took that down. I figured if Cisco can tell you that, then it must be true, right? Now the k values are just key indicators. So there are 5 clearly defined variables in the equation labeled k1 through 5, and there are other variables too. We're not going to get into them here. Bandwidth, delay, reliability, and load are the 4 main ones that you're going to run into. Now, what exactly these k values are, what are they used for? So k values are nothing more than numbers of 0 through 255. So k values simply define how important the other other variables are: bandwidth, delay, reliability, and load, by scaling them, multiplying them by an integer. Now, like I said, I'm not a math whiz, but basically what you do is, the bigger the number, the more scale, the more important they are. So by default, it's just an increment of 1. If you go out there and you go in there and you have some really weird values, you can get into some really weird outputs. Now, k values are not equal to the variables they help scale. They are just They are just an integer value that you would use to indicate how important a particular k value is. So if you wanted bandwidth to be more important than delay, you could use that. Now, by default, k1 and k3 are equal to 1. K2, 4, and 5 are equal to 0. K1 and k2 are bandwidth and delay. So we can manipulate the EIGRP metrics with the metric weights command underneath the global routing process, and go from there. K5 is 0 in the last section of the equation and is not taken into account. I should say if K0. K5 is over here, which is which if this is anything multiplied by 5, or I'm sorry, anything multiplied by 0 is 0. So if it's 0 by default, then anything multiplied against it will automatically be 0. So that's why that is not taken into effect. So it is 0 by default. By default, the last section is not considered in the calculation. Now, the variable bandwidth really means 256 times 10 to the 7th over the minimum bandwidth. So what you would do is you would take 10 to the 7th and multiply that by 256, and then divide that by the minimum bandwidth in kilobits per second. So what that means is you would take 10 to the 7th, multiply that by 256, and take whatever the bandwidth is, and divide those two numbers, so the bandwidth, and divide that by whatever the product of 10 to the 7 times 256 is. Divide that by the bandwidth, and then that's going to give you your bandwidth metric. And then the variable delay really means you're going to take the cumulative delay along the path in tens of microseconds and multiply that by 256. You take those two values, so the delay plus whatever the bandwidth is after you've gotten through your calculation, you add them together, and then that gives you your end-to-end metric. So it's relatively straightforward for the most part, but it's important to understand how the breakdown works. So I actually went through this a while back, and I gave some variables here. So I said if you're going to be taking, so this is 10 to the 7th, so it's, what is that, 10 million? So 10 to the 7th is 10 million, and you take that, multiply that by 256, and you take, so you have 10 to the 7th divided by the bandwidth plus delay, multiply them both by 256, and that gives you your overall delay. So we have now, this is for classic mode EIGRP right here. This is what classic mode EIGRP runs off of. When you get into named mode EIGRP, it actually changes a little bit. You're no longer scaling by 256. You then scale by 65536. And that gives you a much larger value to work with. And you're not going to be scaling your delay in microseconds. You're going to be doing it in picoseconds, which is going to give you a much larger result, which allows you, for the main part, to scale to above 1 gigabit per second. So EIGRP, I believe, has a total top-end metric. It can go up, I think it's what, 3 or 4 terabits per second. It's some insanely large number. So that would be your calculation for that. Now let me get into wide metrics, and then that'll break down what's going on. And then we'll take a look in the next video how the calculation would break down. Okay, so wide metric calculation is pretty straightforward. So classic metric, you're doing 10 to the 7th times 256 divided by the interface bandwidth plus a cumulative delay end-to-end in tens of microseconds. That is your equation, and the delay is multiplied by 256 as well. Now, technically speaking, you could take 10 to the 7th, divide this by the interface bandwidth and the end-to-end delay, and multiply them both by 256, and you get the same response, because you're going to be multiplying 256 by both. So, I haven't done it that way, but you could technically get away with it. Now, with wide metrics, you're actually going to be adding or swapping out, I should say, 65536 from 256. So same basic breakdown, except for your delay is in picoseconds. So delay in picos is 65536 divided by 10 to the 6th. So, and now bandwidth is actually throughput. So you take, it's a little more complicated to run through this, but I'll do my best to explain it. The idea basically is you take K1 and times the EIGRP bandwidth times the wide scale, and divide that by the interface bandwidth. So bandwidth times the wide scale, and the wide scale by default is 128. And so you take delay times, bandwidth times 128, divide that by the interface bandwidth in kilobits per second, and then you have whatever that value is. Then you take K3, which is the delay, and you take the delay times the wide scale of 128, divide that by delay in picoseconds, and then you take that, the default metric is still the same formula, and what you go and you take those values, so whatever the bandwidth result is, whatever the delay value is, you take those and now you put them together and that becomes your EIGRP metric. Fairly straightforward, but it can be kind of complicated in how it actually does things. And then we have this backwards compatibility issue with rib scaling, because by default the iOS rib only supports up to a 32-bit metric. EIGRP named mode is actually a 64-bit metric. So you actually have to do what they call a rib scale, which actually this allows you to choose what the values are actually going to be, and the rib scale allows you to change the metric based off of the rib scaling feature, and not 110% sure off the top of my head exactly what that means anymore, but basically the idea is it's gonna, I believe it's you take this number down, so you go 128 and below, you get a larger number for your metric, and if you take that number 128 and above, you're going to get a bigger number, or sorry, a lower number. It might be the opposite of that, but that's the general idea of how you would do that. So that's the general idea of how you would calculate that out. So I'm not going to run through the actual calculation because this isn't a CCIE prep course, but just be familiar with how the metrics break down. And then in the next video, we're going to actually get into how you would go about determining what's going on. So we'll take we'll break it down for both the classic mode and for named mode, and I'll break down exactly how the metrics are figured out and go from there. So that's pretty much all there really is to it for the most part. Just be aware that there is differences between them and know the differences between them. So EIGRP does it by default. I guess you could say it might be good in some respects to know how to do it manually, but the router does it by default anyway. So it's up to you. It's up to you if you want to know how to do it. So I hope this has been informative for you, and I'd like to thank you for viewing.